Good morning. We're going to present to you, all of you, the laboratory about conservation of energy. The objective of this activity is to verify the law of conservation of energy, which tell us that energy can neither be created nor destroyed. It can only be transformed from one state to another. Conservation of energy, the potential energy at point A is just equal to the kinetic energy at point B of translation and its rotation. So we say at point A, there's the potential energy which is equal to mgh. And then as it moves, you have, or it is equal to 1/2 of mv squared, v is velocity, and 1/2 of moment of inertia and angular velocity squared. Okay, so we start with this activity. As you see in the video, you have to measure the difference of height at point A. So you get the measurement, and then get also the measurement of the height
Okay,
the
are we going to
opposite
release
side,
now?
which is at
Ready for the timer?
so you start with
Okay,
the time
one,
upon releasing this axle. So as you see it, you should start the time until it reaches to this point. Okay, not going up. It should be at that point.
Okay, you can read.
Then you measure it. Okay, that slant distance, which we call it S, from here, from the should mark it here, and then of course, as I have said earlier, you should get that height to the opposite side to get the difference in height of this slant
Yes. Yes, sir.
track.
7.5?
Okay, so that becomes h1 over h2, or h1 minus h2 for the height.
7.5?
Okay, that is
How about
so
here?
h2. The
Ah,
other
you
one
measured
is
earlier, 14.5.
opposite. Okay, so
I think
here should be
measure
h1. So you have h1 minus h2 will give you the after performing the activity. Now you can go to the table for maybe 5 tests or trials. Record with the h, and then record with the mgh, which is your potential energy, and then you have the time that is needed for you to compute for your velocity, which is just equal to 2s over t, and then the kinetic energy of translation, which is 1/2 mv squared, and then your angular velocity, which is just the linear velocity over the radius of the axle, and then the kinetic energy, which is just equal to 1/2 of I, which is moment of inertia, and angular velocity squared. By the way, I, or the moment of inertia, is just equal to m, or the mass of the axle, and then mass of the wheel, and then r squared. R is the radius of the wheel. Okay, so the error of percentage, you can just compute it by the difference of the potential energy minus the kinetic energy of angular and then translation at translation and at rotation, and then divide by the theory. That's all, and see you next time.